Hello everyone and welcome to this video. In this one, we are going to see a better way to set up your C++ projects and solve many of the problems we saw in the previous videos where we used Visual Studio Code configuration files like tasks.json file and the launch.json file. We saw that those files were specific to Visual Studio Code, and you also had a chance to see that the compiler paths were hardwired in those files. These are things you don't really want to do in a professional C++ project. There are many ways to improve on that. There are many tools on the market to do things better. But in this video, we are going to be focusing on CMake because it is a very popular tool within the C++ community. Chances are, if you become a professional C++ developer, you will use CMake at some point. And I believe that many of the popular C++ projects, at least 80%, are using CMake. So it is a thing that is going to help you on your way as a C++ developer. So we will use that. CMake is a build system generator. And if that doesn't make any sense to you, don't worry about that. I am going to show you how to get started with that. It is a tool that is going to take over the job of interfacing to your compilers. And all you have to do is write a script that CMake understands. And CMake is going to use different compilers. If you wanted to use MSVC, it is going to use that. If you wanted to use GCC, it is going to use that. It can even use the Clang compiler. It is very versatile. Another good thing about CMake is that we can use it from within Visual Studio Code, so we don't have to leave our tool of choice. There is an extension that we can install to have it integrated and work really well. That's what I am going to show you in this video here. To make sure you do what we do in this video, please make sure to install this CMake extension in your Visual Studio Code installation. So open Visual Studio Code, go to the extensions tab and make sure that you have CMake. If you search for this, it is going to give you CMake language support for Visual Studio Code. This is the extension I want you to install, but also install CMake tools to have a good experience with us. These are the two extensions that I recommend you install. After you have these extensions installed, make sure you have CMake installed on your system. I am using, let's go inside of Visual Studio Code to see the CMake version I am probably using CMake 28. You can check the version you have by running CMake -- version. And it is going to tell me that I have 328. You need a recent version. I would recommend at least 325, but why not get the latest version? To install CMake, all you have to do is search for it. So CMake install. And you will go to the CMake website. They will tell you ways you can download and install it. So if you go to download, if you go down here, they have binary distributions. You can download for whatever operating system you are on. We have an option for Linux, we have Windows and Mac. So you can download it and install it. If you don't know how to install it, you can search and say your Linux distribution, for example. So for Ubuntu, you can say install CMake 328 on Ubuntu, and you will have instructions. This is really easy to install. For Windows, you just have to download these binaries. I think what I downloaded is 328 and the MSI installer, and you double click on it, it is going to install CMake on your system. If I go on my system here, it should be in the C program files, and we have CMake somewhere. We have CMake, and it is in the bin directory here. You can see that we have a few binaries for it. After it is installed, I think it is going to automatically add itself to the environment variables. So if I do environment variables and go on environment variables here and go to my path variable, let's make sure you can see that. I should have CMake in here. Let's hunt for it. Where is CMake? Yes, it is right here. So this is why I can call it on the terminal. Make sure this is included in your environment variables. Now you have a CMake installed. And in previous videos, I showed you how to install the compilers. So if you don't have any of these compilers installed, please watch the first video. on Windows or the second video on Linux, I show you how to install these compilers. And if you have CMake and these compilers installed, you have already the requirements, and we have also installed the Cplusplus extension here. These are the requirements. Once we have these requirements, we will have to write a CMake script for our project. And I tried to make this script file as minimal as I could, but these are the things you need to set up a basic C++ project using CMake. The first thing you do, CMake minimum required. This is a command that is going to set up a minimum version for your CMake project. There is a project command that is going to specify the name of your project, the version of your project, and the languages that your project is using. CMake supports multiple languages, but in this case, we are using it for C++, and we say C++ by CXX here. The other thing we do, we set the C++ standard that we want our project to use. We want to use it 23, and the standard is set in this CMake variable. This is a CMake variable here. Again, don't worry about these things. Just do everything I do here and try to build the project like I build it, and you will be picking up things as you go. CMake is not as hard as many people make it out to be. It is complex, but it is possible to just use a section of it to do what we want to do with C++. And that's the point of this video here. If you don't know what these set commands do, don't worry, I will show you how we use them when we build this project here. So stay with me, and you will thank yourself for that in your career as a C++ developer. Do another set command, which is going to make sure that this standard is required for our project to build. And what this does is, if you try to build this project with a compiler that doesn't support this standard, the build is going to fail, and it is probably going to give you a message saying that your compiler is old, it doesn't support the features that my application needs. Down here, I want you to experience one of the benefits of using CMake, which is giving you the ability to bring in third-party dependencies. To bring in third-party dependencies, you have to include the FetchContent module, just like we do here. And in this case, we want to bring in the FMT library that many C++ projects use to print things nicely. Before we even talk more about this library, I think we can go on our browser and search for it. Let's say Cplusplus FMT. And it is a library. Let's see the description. So they will probably say it better than I can. It is an open source formatting library providing a fast and safe alternative to C++ streams and C stdio. So it is a good library. I think modern C++ is going to build in features that this library provides, but at this time, not all compilers support this, so we have to use an external library for this. And to use FetchContent, you say FetchContent declare. I am probably losing you here, but don't worry, these are things you have to use in your career as a C++ developer. So we have two commands, FetchContent declare and FetchContent make available, and we say the library that we want to bring in. Where the library is going to be coming from, you specify that through the Git repository option here, and you say the Git tag that you want to bring. In this case, I am going to assume that you will be getting your dependencies from GitHub, but it is possible to get them from other Git repositories as well. So if we go back to the Git repository for FMT that we just looked at, you can see it right here. To get to the link you use, you come to code and copy this link here. This is what I did. I copied that link and pasted that inside of my Git repository option here. And after that, you specify a tag that you want to pull for your library. Let's come back to the Git repository. To get the tag, you come to your Git repository and click on this button that says master or main. Click on this button. And you see that we have an option to get the tags, and your tags are going to be listed here. Let's go back and see the tag that we are using. We are using 1011. It is right here. So this is the tag I am using. If you want, you can use a new tag, but you can also use what I am using here. It's not very old. So this is how you do things. And now, after you do the FetchContent declare thing, you can do FetchContent make available and pass the name that you specified in here. The name here doesn't have to match what you specify in the Git repository here. It can be any name, but it has at least to be relevant to your library that you are trying to pull with CMake. If you haven't used CMake before, you probably think this is difficult, but please do what I am doing here. You will appreciate the benefits of bringing in this library. Once you know how to do this, you will be using the same technique to pull other libraries. For example, if you want to pull in SFML to do some GUIs, if you want to pull in libraries to do encryption and whatever, this is really going to make your life easy. So make sure you spend some time to use this and see it running. After you see it running, you can even read the documentation to kind of reverse engineer your way into CMake because it is a great tool. So after we set up this third-party library that we want to bring in, we will set up an executable. So you say add executable. This is going to set up an executable target. So this is going to be the name of the executable. It's going to be named Rooster. In this case, you can name it whatever you want. And this executable is going to be made up of our main.cpp file here. How do we make our executable use the third-party dependencies that we have brought in? You have to use the target link libraries command. You specify the target that you want to link to other libraries, and you put in this private thing. At this point, I would like you to trust me, so I'm not going to try and explain this because it may confuse you if you are a beginner. But you specify the thing you want to link to in the library that you pulled. In this case, it is fmt::fmt. In CMake speak, this is called the target. But don't worry about this. Once you see this working, I will show you a way to know how to get this name here. So this is our CMake script, and it will be using a standard main.cplusplus file, which is going to be specified in here. So I think I have talked a lot. Let's go to Visual Studio Code and start using this thing. But before we do that, make sure you have the C++ extension installed. Make sure you have the CMake extensions installed. Also, make sure you have CMake installed and one of the compilers that you will be using to build your project. Once you have these requirements, and we are going to open Visual Studio Code, okay, and open a folder. It just needs to be an empty folder. We will be putting in our main.cpp file. And as usual, let's go to our documentation. Let's see, do we have the thing from CPP reference? Yes, we have it here. So we're going to grab the code that we would like to compile using C++ 20 or 23. Let's put in the code. And now we need to set up our CMake script, which is going to be taking over to build our project. Let's create it. We're going to add a new file. You need to name it cmakelists.txt. So let's do that. You need to add an S after. Name it exactly like I am doing it here. And we need to pass in the CMake minimum required command. It needs to be the first thing. And the version is going to be, let's require 325. This is a good version we can use. And we need to specify the project. So let's name our project Rooster. And the languages that we support. And we want C++. And after that, we want to set the CMake standard. So let's say CMake CXX standard. Make sure you type everything I type here. Typing these things is going to help you understand them. So we want 23 as the standard. So let's say 23. And we want to make it a requirement. So CMake a CXX standard required, and we need to make this on. Another thing we can do is to add the executable. So add executable. Okay, it's going to be named Rooster. Let's name it Rooster with lowercase, and it's going to be made up of the main CPP file. Now we need to bring in the FMT library. The first thing you need to do is to include FetchContent. So let's include FetchContent. And after that, we need to say FetchContent declare We will specify the name of the library that we want to pull. In this case, it's going to be FMT. And after that, we will specify the Git repository this is going to be coming from. So repository. And we will go back to the GitHub link and grab the code. So we can copy this link here and bring it back into our project. And we need to specify a tag. So let's say get tag. And I think we did 10.1.1.0. Let's go back and make sure. So let's go back to the Git repository and look at the tags that we have available. And we have 10.1.1. I think this is what we used. Let's grab that and put that into our project. So it's 10.1.1. And now we can go down and say fetch content make available. I have suggestions, but I am not taking them here because I want to type this with you. Now, once we type these lines, fetch content, declare, and fetch content make available, this is going to tell CMake to download the FMT library from this link here and make it available for consumption in our project. And we can tell our main CPP file to pull stuff from this library by running the target link libraries command. So we will say target link libraries and specify the target that we want to pull stuff from our third-party dependency. It's going to be Rooster, and we will put in this private keyword here. And we specify FMT : FMT. And again, I want you to trust me on this thing we do here. By the way, if you want to learn CMake from start to a good level, I have a video series that I am going to link in the description below, so you can watch it to really learn more about all these things I am doing here. But I just want you to start using it for C++. After you finish the video, you can even copy this CMake list.txt file and paste it in new projects that you create and do the things that we do here. In this case, you are just learning. Trust the process. It is really going to be easy for you to use C++ if you invest in learning a bit about CMake. You don't have to learn it all. You can just learn the 20% that will allow you to do 80% of the things that you want to do. You can think about it that way. Okay, now that we have this CMake script in place, we need to tell Visual Studio Code to use it to build our project. And there are many ways to do that inside of Visual Studio Code, but I am going to show you the easiest one in this video here, and that is using kits. The first thing you need to do, you come to View and say Command Palette, and then choose CMake Select a Kit. Or you can even scan for kits to see the kits that you have on your computer. A kit is really a compiler and the tools associated with that compiler to build your project. If we scan for kits, they are going to be scanned, and then we can do View, Command Palette, and then Select Kit. If we do that, you see that they detect a lot of compilers on my system here. But what I am going to do is to choose, for example, Visual Studio and AMD 64 here. Let's try to select this. And now you see that something went wrong with my project. We couldn't find fetch content because I have a typo here. So I should say fetch content. And I said something else. Now let's see if this goes through. And now I have another typo here. Fetch content make available. We should say fetch content make available. Fetch content make available. Let's try to configure again, View, Command Palette, and select a kit, and select the same kit I did earlier. And now everything is going to work. You see that they say that the build files have been generated to this build folder, and now your project has been configured. If you have typos, you can check the Git repository for this video and make sure that you don't have any typos. You can even copy this section of code and paste it in your CMake list.txt file. Once we have this, we need to build our project, but before we build it, Let's take a look in the build folder and see the project files that have been generated. You see that we have generated a Visual Studio project, but we don't have to open Visual Studio to build this project. We can build it right from Visual Studio Code. Now that we have configured our project, we need to build it. Let's go back to Command Palette and say CMake build. You see the option here. You can even hit F7, but I don't like this shortcut because it's not easy to see on video. So I am going to select CMake build, and notice what is happening here. This is going to build the project, okay? And it is going to say that we have built the rooster binary, rooster.exe. This is our binary, and this project has linked against the FMT library. You can see it here. Let's try to run it. It has been generated in build debug, as you can see here. So we can hop over there on our terminal. So let's do that. We can cd build, cd into the build folder, and cd into debug. And if we do ls, you see we have a rooster binary that we can run. If we run it, it is going to say whatever is output by our application here, which is using this structure. But we can even try to use FMT. If you go to the documentation of FMT, you see that to use it, you may include FMT format.h. And for example, you can say FMT print, the sky is blue. I'm not going to try to do anything fancy with it, but you can do a lot with FMT. In this case, I want to use it as a proof that you have pulled a third-party dependency and that you are using it in your CMake project. Something that is not trivial in C++, but CMake is really making this easy for us to do. Let's try to build the project again. We can hit F7 if we want, because you already know that. So the build is good. You see that we can use FMT print. If we run the application, you can even run the application through this run button here. If you do that, it is going to run the application. You see that it says the sky is blue on the same line. If we want, we can put a new line character here. So let's say \n and put the needed semicolon and try to run again. Okay, it's going to run and it is going to say the sky is blue. Let's see that we can debug. And to debug, you just put a breakpoint somewhere. Let's put that on line 20, for example, and hit this debug button in the status bar. If we hit it, you see that our binary is built. It is plugged into the debugger, and we can step through things, for example. But before we step through stuff, you can hover over things to see what they are made of. This is really cool. Another thing you can do is to hit the button here to step through stuff. And you can even look on the left here to see the local variables. If you go here, let's step over this and look at the local variables. You see we have our points here, and we can really do things with this. And now you can build, run, and debug an application using CMake. Another thing I want you to see is how you can add new files to this. So if we want to add a new file, you can add a person file, a header file, and you add a person CPP file. And I am going to grab the code from my repository because I don't want to type these things. I can steal these files from my previous projects that I did. So I am going to copy the header file here. So let's copy the code for our person class and put that inside of Visual Studio Code here. We are going to steal the code for the CPP file and put that in place. And let's go to CPP. I swapped these things. So let's grab the code for the CPP file and put that in the CPP file. I can select this, take this out, and put that here. Let's go back to the header. Sorry for this, but this happens when you are working on projects. So copy and go to the header file and put that in place. Now, if we want this to be picked up by our project, we need to go back in the CMake list.txt file and add this to our executable command. We can say person.cpp. We don't need to put in person.h because person.h is included by person.cpp. But if you want, you can put it there. I see some people do that. It's not going to hurt. So for example, you can do person.h. And this is going to also work. I think this is going to work. You see that the build files have been generated. Every time you modify the CMake list.txt file, Visual Studio Code is going to pick that up and try to reconfigure your project. And now you can run the application. I think we can stop debugging before we attempt to run it. So let's try to run it. It should run and give us output here. But now we can create a person object. So let's go to the main CPP file and show you that you can do that. So we can say person. Oh, we need to include person first. So include person.h. And then we can create a person object p and p eat, for example. And this is going to do what we want to do. Again, we need to build the project and run it, but you can just hit the run button here, which is going to build the project and run it in one go. You see, it is saying I am eating here. You can really do all kinds of crazy things. The good thing about CMake is that you can easily also switch compilers. So for example, if we want to build this project using the GCC compiler that I have installed on my Windows machine, all I have to do is to find the location of the build directory here, reveal in Explorer. I am going to close Visual Studio Code because it is using it. And I'm going to nuke this build folder and open Visual Studio Code again. So the build folder is gone. But what I can do now is to view command palette and select the kit again. Now I am going to make sure to choose the GCC compiler that is installed in my CMake directory. So it is GCC 13 here. I am going to select it, and the CMake is going to configure my project to use that compiler to build my C++ code. You can see that it is using GNU 13.20. It is in this location on my system. It is going to download the dependencies. So you can see that my build files have been generated in this folder. If I go in the build folder, you see I have a deps folder, an underscore deps folder. If I go in, you see that I have FMT downloaded and built, and my project is going to link against it. But now I am using the GCC compiler. Hopefully you can see how powerful CMake is. We can still do the things we did earlier. For example, we can hit the run button to run the application. But before we run it, we need to build it. So let's hit the build button here. This is going to try and build the project using the GCC compiler on Windows. And the build is finished with exit code 0, which means that the build was successful. Now we can try to run the project. I don't know why it's not running. So let's go to terminal and go into the build directory. And we have Rooster. So it is in here. It has been built successfully. Let's see if we can debug it. We can hit the debug button here. And it is not working for whatever reason. Let's try to close Visual Studio Code and open it again. And if we try to run, now it's going to run the thing. Okay, it's going to build the project and run it. Now it is running. If we try to debug, we will debug the project and hit the breakpoint in a minute. You see we have hit the breakpoint, and we can do all these things that we do with our debuggers. But now notice that we are using the G++ compiler. You can even use the Clang compiler, but it gave me problems when I tried debugging. So let's try to do that because we can do that with CMake. Again, I am going to close the project and delete this build folder and open Visual Studio again, Visual Studio Code I mean, and we will start doing our thing again. For example, view command palette and select a kit. We want to select a kit to build with. Now we are going to be picking the Clang compiler that is installed in our MinGW directory, and we are going to hunt for that GCC Clang 16. We have a Clang 16 installed in our CMake folder. I am going to pick this. And again, it is going to attempt to configure my project using that compiler. You see that we are using Clang 16 here. The build files have been generated. Now we can build by clicking on this build button here. and it is going to build the project. The build is finished with exit code 0, which is code for success. Now we can run the application. So it is going to run without a problem. But if we try to debug it, let's hit the debug button here. It is not going to be working. And I didn't have enough steam to research into why this is not working. But if you want, you can just use MSVC and GCC. That's going to be enough. If I have more time, I will try to research on why the Clang compiler is not working here. But now you get the gist of it. It is really good to use CMake to set up your things. Another thing that is good about CMake is that this project is going to be more or less understandable by other IDEs. If I take this project, for example, and open it in Visual Studio, it is going to understand it and be able to build it because most IDEs understand the CMake language and they can process this CMake list.txt file. I think I have this project on Linux, so I am going to open it there. Let's open a remote connection to my Linux box. And I am going to open a project that looks more or less like this and show you that we can really do these things here. So let's open VS Code CPP here and say CMake with kits. This is the folder we are going to open. You see, we have a CMake list.txt file that looks more or less like what we did here. It is going to be pulling FMT and using it, but the main CPP file is not going to be looking like what we had before. But this is not a problem. We can even copy the code and bring that in here. So if we have the code here, copy, put that in front of everything. No, we don't do that. What do? We can grab things in sections. For example, we can grab stuff from the main CPP file. We can do all these things. Let's do that. We put the code here in front to be used, and we grab the declaration of the structure. We put that in front of the main CPP file. This is something we can do. Okay. And we include the files that are needed. We have compare, IOStream, and set. Let's put those in place in front of FMT. Now we can do the things we did on Windows. For example, let's make sure we are using Cplusplus 23. We are. Now we can view command palette and select a kit. And it is going to show me compilers installed on this system. I will be picking GCC again. So let's choose our GCC version, which is GCC 11. You see it is in user bin G++. It is showing the compilers on my Windows machine because this is using Windows subsystem for Linux. But don't use these. Use the Linux compilers, user bin G++. This is what we are going to choose, and it is going to configure the project again. It is going to pull the dependency, which is FMT, and build it. We will wait for the dependency to be built. You see, build files have been generated to this folder. If you go in the build folder, you see that we have the files in here, and we can build the project by hitting build. So what we need to do is to hit the build button here. And build finished, and build finished with exit code 0. This is good. We can hit the run button here and it is going to run, and everything is really working fine. If you want to get the status bar that I have here, you have just to put a settings file in your .vs code folder and put in this setting that you want the status bar to be visible. This is what you need to do. Again, you can get this code from my GitHub repository. This is really all I had to share in this video, showing you how you can use CMake to build your C++ projects from within Visual Studio Code. I showed you that this works both on Windows and Linux, and we don't have to mess with JSON configuration files like we did in a few previous videos. But again, this is not the best way. There are other ways, and I will show you how to use preset files in a next video. And in another video, I will show you how to go crazy and use C++ modules, which is really the future with C++. But for now, I hope you enjoyed the video. If you did, please make sure to like, share, and subscribe. Leave a comment to let me know what you think. If you want to learn about CMake, I have an extensive CMake series. Make sure to look in the description below and you will find a link to watch the entire series. And let me know what you think, guys. I am going to stop here and I will see you next time.